Finally, let's go ahead and take a look at one more sample informative student speech. And in this one, we're going to be watching Landon, who's going to be explaining a few scientific concepts. So let's go ahead and take a look at this. As with all the other sample speeches, especially when we're trying to reaffirm our understanding of the rubric, I think you would benefit by having a copy of that rubric there and doing a couple of things. Watching the speech and flowing it, and then going back and reflecting on the speech in terms of those categories. Not only what is, in this case, he doing well or needs improvement on, but how might he do it differently or how might he do it better. Because again, we want to get to this point where we're blending our abilities to be a speaker and a speech critic. Hopefully so that you can critique your own speeches and improve upon your own practice through the analysis of others. So let's go ahead and take a look at Landon's speech.
For thousands of years, humankind has been fascinated in the earth beneath our feet, but even more so in the possible worlds that lie above our heads. The potential for intelligent life in the galaxies above us is something that has fascinated us and has entered into the scholastic and scientific realm over the last century. That's precisely what we're going to talk about today, the possibility for intelligent life contacting us on Earth within the galaxies above us. Now, to do so, we're going to look at two scientific principles that are used by astrophysicists in the field. First, we're going to look at the mathematical possibilities behind intelligent life contacting us through an equation known as Drake's equation. After that, we're going to look at attempting to answer that question as to why, if intelligent life exists, haven't we been contacted yet? To do so, we're going to look at something called Fermi's paradox, which hopes to answer that question as to why we haven't had intelligent life contact us. So let's begin with that first one, the potential for life on other planets, whether it's a possibility or not. Now, to look at this, we're going to use something called Drake's equation, developed by an astrophysicist by the name of Frank Drake. Now, he was looking to determine how many possible planets existed in our galaxy that could suit intelligent life, that life could survive on. Now, there are a number of principles behind this mathematical equation, and we're going to go through each one of those step by step. First, we need to look at the number of hospitable planets within our galaxy. Now, the number is estimated to be upwards in the billions. There are millions of stars out there with even more planets that surround those stars. That number of possible habitable planets is quite large. Next, we need to look at the fraction of simple life that might exist. This is bacteria, things of that nature. Once again, we have a pretty good evidence to show that this is rather abundant within the galaxy. We find it on our planet. We find fossils of it within meteors and asteroids within our solar system as well. That number is quite large. But the next element we look at is the fraction of intelligent life, of civilizations that could exist on these planets. Now, this number is not nearly as high, because as we know, Earth has billions of species on it, but only one of them is intelligent life. Only one of them has the ability to contact outwards. We can't expect every planet to have something like us on it as well. Now, finally, the final element of the mathematical equation of Drake's equation is the fraction of intelligent life that is around now. Now, this is actually our smallest variable. It is extremely low. If we look at our own time frame, humans have been around for about 3.2 million years. The reality is the Milky Way is 13.2 billion years old. To put that into scale, we exist in 1 second of a 24-hour clock. The likelihood that another intelligent species exists in that same 1 second as us is very low. When we put all these together, we see that the possibility for intelligent life exists, but it's a low probability. But if it's out there, we have to ask ourselves, why haven't we heard anything yet? Why haven't we been contacted? And that's when we look at the next element of our principles that we're looking at today. And that's known as Fermi's paradox. Now, this was developed by Enrico Fermi and Michael Hart, two astrophysicists, and it was famously developed over a cup of coffee with a large number of astrophysicists in a cafe when Fermi simply asks, where are they now? They were looking to answer that question, and they offered up a number of possibilities as to why we haven't been contacted as of yet. And we're going to walk through those today. Now, the first element that he introduced was the possibility that these civilizations are just too far out. The Milky Way is so big we'll simply never see them. Now, our galaxy, the Milky Way, is 100,000 light years in distance. That's 6 trillion miles. That's a lot of distance to traverse, and simply we may never be able to effectively do that, and may never effectively be able to communicate out that far. And the next element is that these civilizations have existed, or they do exist, but they simply can't contact us or have destroyed themselves before they reach the potential to do so. Now, what this element looks at is the possibility that simple or intelligent life exists for only short moments of time, that elements of the solar system, such as asteroid impacts, solar flares, destroy a lot of civilizations before they reach the ability to communicate, or that they destroy themselves through the equivalent of a nuclear war, something not unheard of even on our planet. Now, the next element Fermi's paradox looks at is that possibly these intelligent life forms do exist, but they don't want to contact us. Now, this is very much like looking at the relationship between us and the ants that live around us. Ants aren't really aware that we exist above them, and we don't interact with the ants. That's the mentality that this element of Fermi's paradox looks at when looking at intelligent life in the galaxies above us. Now, the final element of Fermi's paradox is the possibility that there simply are no intelligent life forms out there, that we are alone on our Earth and there's nothing left or nothing else out there for us to contact. Now, all of these were potential answers as to why we haven't been contacted yet, which is what Fermi's paradox looks to propose. So when we take a step back and look at what we have in front of us, is that the possibilities for intelligent life out in the galaxy are very slim, but they're not impossibilities. And while that may not sound as the most hopeful thing out there, the reality is it just means we have our work cut out for us. That when it comes to searching and contacting intelligent life, we've got a lot to do. But we can do it, and we have that technology.